Hello and welcome to today's presentation. My name is Ryan Berry and I'm the Business Development Manager here at Aeromotive Services. Today's presentation will be wire to fiber, repair versus replacement. Let's go ahead and make the connection. A little history about our company is that Aeromotive Services was founded in 1996, so we have nearly 20 years worth of wiring knowledge underneath our belts. We've grown into a 4,000 square foot factory and office facility. Our manufacturing of high-quality connectors and housing has left us with a reputation that is one of the best in the industry. Some of our capabilities are as follows. We're able to supply OEM connectors and terminals. We're also capable to supply wires such as aluminum wiring as well as fiber optic cabling that will be discussed further in this presentation. We have access to controlled drawings. We can also 3D draw and print as seen in the upper left-hand corner here with that GIF. Software to lay out and route harness designs as well. We also have a preset process to allow us to process non-standard wires such as high-temperature wiring that has a glass composite construction, which is also found in fiber optic cabling. And we also have in-house injection molding, as well as stated before, 3D printing for obsolete parts. In order to kind of go we have to first have a little history on copper wiring itself, especially when it's compared to something as advanced as fiber optics. Copper is a key component in vehicles since the original Model T Ford that was back in 1916. In 1948, the average family car contained only about 55 wires, amounting to an average total length of 150 feet. Today's luxury cars on average contain some 1,500 copper wires, totaling about 1 mile in length within that vehicle. Copper wiring can be found in several applications in a vehicle, including the braking system, infotainment systems, and even collision detection sensors. It's so commonly used because of its resistance to extreme conditions and its inexpensive manufacturing costs. Now, to compare the two, fiber optic cabling is immune to electromagnetic energy because it doesn't conduct any electric current. Copper cabling, if not installed properly, is vulnerable to EMI, which is electronic magnetic interference, or what causes a little buzzing. If you've ever been outside under a light pole and heard it buzzing, that's the same exact thing that will happen within a copper cable. It's also lightweight. Optical cable weighs less than comparable copper wire, usually around 20 to 50% of that original weight. It's also non-flammable. Fiber is dielectric, and that means that there's no electric current that flows through it. Copper, on the other hand, does carry a current and can cause a fire hazard if cabling is old or worn, and you'll see that typically through just typical use. High bandwidth. Fiber has a higher bandwidth. I give you an example. Fiber can send a signal for over 200 kilometers without any real loss of quality, as where copper wire can hold about maybe 350 separate phone calls in a cabling wire for at least your telephone. Fiber optics can hold up to 31,000 phone calls, just to give you a quick example. It's also secure. It's very difficult to hack into a fiber optic cable just because it only reads the absent or actual sign of light, and there's no background radiation when it comes to it like you will find in copper wiring. Some key features that also separate this from copper wire is that it's a controlled signal from one point of frequency. That means there's only one key contact that it's reading from and it's sending out to. It's a single system. Everything's transferred at the same beat. There's no loss even when the battery is disconnected. No central processor, so you don't have to worry about any sort of source going bad and not sending that signal out as long as there's light flowing through it. There's no buffering. Also, it automatically reconfigures peripherals to when it's added with perfect synchronization. So once you have your fiber optic cable plugged in, it'll all go at the same timing. It's all set to one spot. You won't have to worry about it heating up, losing any sort of its signal through that process within the system of the car. So to kind of go further how it does work, network communicates within a vehicle in a loop, usually going about 100 megabits per second, 150, which is an exceptional amount of data from one single current place. Incoming light is converted into electric signal. Think along the lines of binary, zeros, which is the absence of light, and 1, which is the actual strength of the light itself going through and being read through that processor. After that signal is transferred through, a light pulse is then sent to the next component. And as I said before, it's read as 1 active or 0 as inactive. It's very simplistic coding within the vehicle in a very complex form, just made out of glass tubing that is mirror shined. And that's where a lot of the difficulties in the repairs, which we'll be discussing further on, come from. So when you're in an accident, there's an ability to repair that fiber optic cabling. Such examples are if it's the national back order, if there's obsolete parts involved, as well as fire, collision, and rodent damage. All of these can, occur on a daily basis, and it's something that we're able to repair at any given moment. There's optional configurations that we use within the vehicle itself that we can readjust and remanufacture on our end to make sure that it's up to its standard. And then we also follow any sort of guidelines when it comes to SRS or ABS or any other systems as well. Give you some examples. Rodents are immensely attracted to the oil that is ran through the wire when it's dyed. So what ends up happening is it's usually a peanut-based or a soy-based product, so that attracts the mice, and that which causes that to be a rather expensive snack on your behalf. Just because fiber optic cabling is always found within another system that might also include wiring and traditional other wiring components, will always be a threat until technology advances itself. So when it comes down to the damage of fiber optic cabling, there is a possibility, especially in collision, how to repair that particular fiber optic cabling. All you will need is the tooling, the repair kit, and then you will have to do the process of cutting and stripping that particular wire, make sure that the end face is prepared and ready to go for a terminal, crimp it, and then we have it measured up exactly in order to make sure that that light is going in the optimal direction. Just because, since it is essentially a bunch of glass mirrors inside of that cabling, if it gets scuffed in any way or it's not crimped correctly, that signal will be lost, and you'll actually find signal strength. And these two gifts on the side of us will show you exactly how you're supposed to do it. It looks a lot simpler in these videos here, but it's much more complicated if it's not done in trained hands. So just another example of what we go through. There be time to replace it completely. But fiber optic tools are needed as always. If we go against anything else and we try to use a traditional crimper, we're literally just going to be breaking a mirror with inside of a tube, and it's going to become worthless. So cutters, strippers, and then the crimpers, all of those are going to be needed for this repair, which are just shown right here in these pictures. The one here with the gloves being, of course, the cutter and stripper, and then the other devices are the measuring tools here to make sure that the light is going at the optimal direction to have that signal pushed through the cabling itself. So since there is going to be multiple systems, there's no such thing as a true fiber optic system in cars as well. We do have kind of a general guideline, especially knowing the difference between your cabling and how to handle such things in those systems inside of a vehicle. So our main staple here at Aeromotive Services is why replace the whole harness for one connector? Well, the reason you want to do that is just go ahead and get the connectors and everything fixed is that, of course, it reduces your costs, it prevents your total losses, it expedites turnaround time, keeps the repairs in-house, and it satisfies your customers. We're going to make sure that everything's working order, that it's going to be quick, and it's going to be up to its OEM specifications no matter what. So another limitation within these systems, especially when it comes down to traditional copper wiring, is the 6-inch rule. There's no repairs within 6 inches of a termination point just because we need to have workability. You have to be able to stagger these cabling and these wirings in order to make sure that that the signal isn't lost. If it's not staggered correctly, like what we see here where it's marked as wrong, that's within 2 inches of termination point, and this leads to electronic resistance. The current will still flow through the cable, but it's going to be delayed. One such example is that we had an individual that had a headlamp problem, and what was ended up happening was because of a inefficient splice here too close to the termination point, one headlight was turning on a little bit quicker than the other, just enough for the customer to realize this and see it. So it's all about trying to make sure that at least when you do have your work done, make sure that it's spread out correctly, not too close to a termination point, or you might have issues down the line, especially when it comes down to the increased resistance and the lifespan of that cable itself. The other one is the 6-wire rule. So with copper wiring, what you'll see a lot of the times too is that the shop will go ahead and get repair, and they'll bundle it all together into one giant meatball, and that will also cause EMF. One real-life example here, what we had is that a customer got into a little bit of a car accident, ended up getting a repair done. Everything worked fine. She started driving home, but of course, when she turned on her radio, she kept on hearing a buzzing noise, a little bit of ringing. And what ended up happening is that they went through the whole car trying to find out what was causing this problem. They pulled out the dash, and what became a pretty hectic job. But what they found out was that it was just simply the bundling of wiring, which was, kind of clustered up together, which caused a little meatball. And so once we ran that back and we staggered it a little bit better, that magically went away. It's as simple as how it looks and how it's being produced that cause a matter of difference within the vehicle, especially when it comes down to customer satisfaction. So in other ways, you want to make sure that you know and what you're repairing are specific and exact to the vehicle. Make sure when it comes down to shielding wiring, that means anything that has a foil, anything that's going to be outside of a bare cable that's within the system, that you follow the guidelines and procedures set by the OEM standards. Make sure that you're not wiggling or even giving different gauges of wiring or different metals, for example, or splicing copper with aluminum will cause immense troubles, especially when it starts to break down. Make sure that the SRS wiring is, of course, up to the OEM's guidelines and that it's followed, and also follow your own procedures within your own companies. And fiber optic cabling, as we've talked about before, you'll need a repair kit, and you have to make sure that the measurements are correct, or that vehicle and that signal will not be working properly. There might be slight delays or loss of information transferred. So to kind of go for the rules of thumbs for shielded wiring, no more than 25% of that shield can be missing at any given time. If that's the case, we have to make sure that we either replace or repair that wiring accordingly. Make sure that you know what the type of cable is. Make sure that you don't replace, if it's a foiled area, that you're not just putting something that's dual channeled, or you're just using a coaxial cable to make that difference. Make sure that you have the right wiring available. And then, of course, if you ever have any questions, you can always send us a picture, enter our website at aeromotive.us. You can take it with your phone, whatever it might be. And we'll go over that, how to contact us at the end of this presentation here. So with fiber optic, it follows the same guidelines as well. Make sure that no more than 25% of that particular shielded cabling or that fiber optic cable is missing at any given time, or that 1 inch of that surface area is missing. If that's the case, we need to get that repaired, or we may need to completely replace it based off of the damages available. And then, of course, we want to make sure that we test the system, that the line is either going through or that the electrical current is going through, given whatever the circumstances may be for fiber optic and or copper cabling. And so make sure as well that when you're running your wires, you make sure that everything is ready and the temperatures are correctly done within a shop. You want to make sure that if the vehicle, for whatever reason, is going to go through a spray booth, that it's not above 176 degrees, just because it can get immensely hot, and that can cause warping, cause moisture to get inside the cabling. It can flame up the lenses inside of an optic cable. It can do a number of things. And then, of course, make sure for painted surfaces that satellite antennas such as that will have a good ground, or static noise will also result. So even the way when it's being repaired can be a difference of it working and not working depending on the environment. So make sure that the cablings are correct, make sure the temperatures are correct, and then everything is ran back and tested beforehand. So that has been our presentation on fiber optic cabling versus copper cabling. And then we also do pigtails, connectors, wires and harness remanufacturers, as well as specialist assemblies. So anything it comes down to at Aeromotive can work anything on the vehicle, or even something more exotic such as industrial equipment, even medical equipment and RVs, etc. high mix, low volume, quality control is all under the standards of ISO 9001, 2015. If you want to ever get a hold of us, you can reach us at aeromotive.us or parts@aeromotive.us directly to email, or you can just give us a call, 224-535-9220. Thank you so much for your time today. Be safe and have a wonderful day.